Modern RF systems, from advanced communications to radar, demand compact, efficient front-end modules that deliver both high power and low noise. Traditionally, engineers relied on multiple discrete components to achieve these goals, which had a number of disadvantages. Fortunately, however, the Qorvo QPF5001 Dual-Channel 12-watt transmit-receive module breaks through these challenges. The QPF5001 integrates a power amplifier, low noise amplifier, and limiter into a single package. This design delivers exceptional performance while reducing board space by half compared to discrete solutions. In this tech guide, we'll explore what makes the QPF a standout solution and how to effectively integrate it into your next RF design.
Step 1. Standout features of the Qorvo QPF5001.
In high-performance RF systems, designers need solutions that balance power, sensitivity, and compact design. The Qorvo QPF5001 delivers all of those, so let's jump into some of its standout features. The QPF is designed for operation in the X-band 8 GHz to 12 GHz, and that's a critical frequency range for communications and radar applications. On the transmit side, it delivers 12 watts of saturated output power, enabling long-range, high-fidelity signal transmission. On the receive side, it achieves an impressive 1.5 decibel noise figure, ensuring excellent sensitivity and signal clarity even in demanding environments. But what really sets this module apart is its multi-die FEM architecture that integrates a power amplifier, a low noise amplifier, and a built-in limiter. All of this comes in a compact 6mm by 5mm laminate overmold QFN package. By reducing board space requirements by nearly 50%, engineers can simplify layouts, cut costs, and boost reliability. Next, we'll look at how the QPF5001 ensures protection and reliance.
Step 2. Integrated limiter for device protection.
In high-power RF designs, protecting sensitive circuitry is essential for long-term performance and reliability. The Qorvo QPF5001 addresses this challenge with an integrated limiter that safeguards the low-noise amplifier and other front-end components from harmful surges or signal reflections. Unlike external protection circuits, the limiter is built directly into the module and optimized for the X-band operating range. This design not only reduces insertion loss, but also streamlines integration, minimizes board space, and enhances durability. As a result, engineers can develop compact, high-performance RF systems that remain robust even in unpredictable environments. Next, we'll take a look at its dual role in transmit and receive paths.
Step 3. Dual-channel performance.
The QPF5001 is engineered as a dual-channel FEM, meaning it can seamlessly manage both transmit and receive functions. For transmission, the integrated power amplifier provides high output levels with excellent linearity, making it suitable for demanding waveforms and wideband modulation schemes. For reception, the low noise amplifier ensures weak signals are captured with minimal degradation. This integration streamlines system architecture, allowing engineers to replace multiple discrete blocks with a single compact solution. Next, we'll talk applications.
Step 4. Qorvo QPF5001 applications.
The QPF5001 is versatile and well-suited to high-frequency communication links and radar platforms. In radar systems, the wide X-band coverage and dual-channel design enhance detection range and resolution for applications such as air traffic control, weather monitoring, and surveillance. In communications, its high output power and low noise performance support long-range wireless backhaul, satellite terminals, and secure links for both commercial and defense sectors. With its compact footprint and integrated protection, the QPF5001 enables next-generation designs that are smaller, lighter, and more efficient. Up next, we'll go over the tools and considerations for system integration.
Step 5. Design and integration guidelines.
To fully leverage the QPF5001's capabilities, careful integration is required. Start by connecting the module to a circulator, as it is pre-configured to simplify routing between transmit and receive paths. Thermal management is also critical, especially with up to 12 watts of output power. Adequate heat sinking and thermal vias under the package help dissipate heat efficiently. Correct biasing and power supply are important too. Following Qorvo's reference designs for PA and LNA stages helps ensure optimal performance. Next, good layout practices such as keeping RF traces short and matched, minimizing via inductance, and maintaining controlled impedance reduce signal loss. Finally, validate system performance across the full 8 to 12 GHz range under lab and field conditions. Following these steps helps engineers integrate the QPF5001 into compact, reliable RF systems. Next, we'll go over some tips for optimal operation.
Step 6. QPF5001. Best practices for reliable operation.
To maximize system longevity, a few best practices go a long way. Minimize unnecessary thermal cycling to reduce stress on the package. Also, limit the number of solder reflows and carefully follow recommended reflow profiles. You'll also want to implement thorough testing, and not only for RF performance, but also for environmental factors such as vibration and humidity. Finally, plan firmware and system updates to align with operational requirements, avoiding unnecessary disruptions in the field. Following these guidelines helps maintain optimal performance and extends the lifespan of the module in demanding applications.
Conclusion.
The Qorvo QPF5001 combines a PA, LNA, and limiter in a compact QFN package, having board space while delivering high power, low noise, and built-in protection. With wide X-band coverage, robust performance, and simplified system design, it is an ideal choice for advanced communications and radar systems. To learn more or to purchase the Qorvo QPF5001, visit Mouser.com today or click the link below. And be sure to check out our other tech guides, because smart minds never stop learning.